Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be talking about MergeSort. MergeSort is a powerful, efficient, and widely used sorting algorithm based on the divide and conquer approach. Today, we'll talk about the code step by step, breaking down how it splits an array, sorts the parts, and merges them back together. Let's get started by talking about the actual MergeSort method. So let me just code that real quickly, sorry. Give me 1 second. Alright, let's start. Similar to other sorting algorithms like quicksort or bubble sort, it declares public static void so any of its components can be used throughout the class without making it an object. The way it differs is that instead of only having int array as a parameter, it actually has three parameters: int array, int left, and int right. This is used for the actual merging part of the algorithm, which we'll get into a bit later. So let me just finish the code. So this part shows an error because we haven't actually started the merge method yet, which is pretty long, and we'll get to that in a second. So this is the MergeSort method. Its job is to divide the array into smaller parts, sort them, and then merge them back together in sorted order. As I said before, the method takes three parameters: array, which is the array that we're sorting; left, which is the starting index of the array; and right, which is the ending index. The first line checks if left is less than right. If it's true, that means there's more than one element in this range, and we need to keep dividing the array. Next, let's talk about this line over here. Int mid equals left plus, in parentheses, right minus left over 2. We calculate the midpoint of the array using this line. The formula avoids overflow, and it gives us the middle index of the current portion of the array. For example, let's say the left index is 0 and the right index is 6. The midpoint will be 0 plus 6 over 2 minus 1. This splits the array into two parts: the first half from index 0 to 3, and the second half from index 4 to 6. Next, let's talk about these two recursive calls to MergeSort. First, we call MergeSort with our parameters being array, left, and mid. Then we call MergeSort array, mid plus 1, and right sort the right half. This line up here sorts the left half, if I didn't say that. These recursive calls keep dividing the array into smaller and smaller parts until each part contains only one element. At that point, each part is considered sorted. So on this line, once the left and right halves are sorted, we call the merge method to combine them into a single sorted array. The merge method is where the sorted pieces are brought together in the correct order. Let's take a closer look at this part. Okay, this might take a bit long to code, so I'll code it completely and then give an explanation because it's quite lengthy. Oh, my bad. I did not give it a name. Sorry. Alright, let's start. As you can see by the sheer amount of code, we know why it's so powerful, due to its complex, inside mechanics. This is only half of the actual merge method, so we still have a long way to go. Alright, I think that's it for the merge method. So let's move on to actually explaining it. So the merge method combines two sorted subarrays into a single sorted array. First, we calculate the sizes of the two subarrays. So we have int n1 equals mid minus left plus 1, int n2 equals right minus mid. So n1 is for the left subarray and n2 is for the right subarray. Then we create two temporary arrays, left array and right array, to store the elements of these subarrays. Using for loops, we copy elements from the original array, which is int array, into these temporary arrays. So using these lines and these lines, we just copy the existing elements from int array into these two temporary arrays. Now let's talk about the while loops. Now we merge the two temporary arrays back into the original array. The first while loop compares elements from both subarrays. Whichever element is smaller is placed in the next available position in the original array. This process continues until we've processed all of the elements from at least one subarray. After the first loop, one of the subarrays might still have remaining elements. The next two while loops, which are these two, handle this case, copying any leftover elements from the temporary arrays back into the original array. By the end of this method, the original array contains all of the elements from the two subarrays sorted in order. Next, let's actually see this in action. So now this is how you actually call MergeSort. We have our beginning array, which is the array that we have in our parameters, the one that we're sorting. Left is always 0 because Java is 0 index. That's always the starting index. And right, it would just be the length minus 1 because we're accounting for that 0 index. Now let's see MergeSort in action. There you have it. Everything sorted correctly. To summarize, MergeSort uses a divide and conquer strategy to split the array into smaller subarrays and sorts each part. Then it merges them back together in sorted order. MergeSort is efficient with a time complexity of O of n log n, which I'm just going to type here. Right? So it has a time complexity, which makes it a great choice for large data sets. Thank you for watching the Super 7 programming tutorial. I hope you learned something about MergeSort. Be updated for more Super 7 content releases soon.